Hi all, so this next unit and couple lessons is going to be on differential equations. And so you know what equation means, and differential, as you know, it's just differentiation, derivatives. So these are really just equations of derivatives. So that's true. A differential equation is the equation relating one or more functions with its derivatives. And these are used naturally all around us, all around the world. So whether it's physics, biology, econ, engineering, it's used everywhere. In fact, we're just doing a little small snippet in this course, but there's a whole class in college just on differential equations. Actually, there's multiple courses in college just on this topic. So it's a very important subset of calculus. Again, so differential equations are just equations of derivatives. So you've seen some before. So if I say dy dx is 2x, and we, of course, that's a differential equation. It's an equation of the derivative. Of course, we know this means that y is x squared plus c. So if you've seen differential equations, we're going to dig a bit deeper into them. And we're going to look at differential equations that you can't solve, such as like dy dx equals 2x, so you can solve already. We're going to look at differential equations like this, which we will learn how to quickly solve. And then we're also going to look at differential equations like this, which we cannot solve. And we'll try and figure out what we can do with these equations, even if we can't solve them. Because there's much more to differential equations than just solving them, so to speak. But before we do any of that, we're just going to look here at this lesson, just getting comfortable with differential equations and learning how to verify solutions. So just basically taking derivatives and checking that the equations check out. So let's say we have the differential equation x times dy dx equals 2y. We just want to verify. So similar to what you do in trig with trig identities. We just want to show that y equals x squared is a solution to that. So it is a solution, we just want to show it. So since y is x squared, I know that dy dx is naturally 2x. And you can just follow along here. So x times dy dx would be x times 2x, which is 2x squared. And since y is x squared, that's literally 2 times x squared or 2 times y. And voila, we just showed that x squared is a solution to this differential equation. Whereas if I said y equals x cubed, then dy dx would be 3x squared. And if I plug that in, x times dy dx would be x times 3x squared, which is 3x cubed. And since y is x cubed, I need 3x cubed would be 3y, not the 2y. So you can see that x cubed would not be a solution to this. All right, now we're going to actually solve for k to make 3e to the 2x a solution to this. And I see here that I need the second derivative, the derivative, and the function. So I know y is already 3e to the 2x. So y prime is 6e to the 2x, and y double prime is 12e to the 2x. So honestly, I just plug in and solve for k. So 2y double prime will be 2 of these. That's 24e to the 2x. Minus 3y prime will be minus 3 of these. That's 18e to the 2x. And ky will be plus 3ke to the 2x has to equal 0. So if you factor out the e to the 2x, you have to 24 minus 18 plus 3k has to equal 0. So k is in fact negative 2. Okay, so now you're going to try these few problems out. And I recommend that you hit pause, try them out, and then hit play. So you try these before looking through what I did. Okay, so we'll start with number 1. Y equals e to the x squared. Verify this differential equation. So I see I need y prime and y double prime. So y prime, you do the chain rule, so it's 2x times e to the x squared. And y double prime, you have to do the product rule, so it's 2x times the derivative e to the x squared, which is 2x e to the x squared, plus derivative of 2x is 2e to the x squared. So if I clean that up, I get 4x squared plus 2e to the x squared. All right, so I need I'm going to verify. So y double prime is 4x squared plus 2. e to the x squared minus 2x y prime minus 2x times 2x e to the x squared minus 2y is minus 2e to the x squared. So that equals 4x squared plus 2 e to the x squared minus 4x squared e to the x squared minus 2e to the x squared. And I think you can see it, but if you distribute that out, you'd see that these all cancel. And as expected, we get 0. We knew this was the case. We were just asking to verify or prove it. All right, so I'm going to do that again. So we need y prime, y double prime. So y prime is 4 cosine 4x. Y double prime is negative 16 sine 4x. So y double prime, we're just going to plug in here. So negative 16 sine 4x plus 3y prime plus 12 cosine 4x plus 16y, 16 sine 4x equals, so your negative 16s cancel out, that equals 12 cosine 4x. Oh, that's a typo. So this should verify to equal 12 cosine 4x. And there we go. So once you fix the typo, it checks out there. All right, so again, we're just doing the same case here. And we're looking at number 3. So let y equals that. And we are asked with simplifying that expression. So I need up until my third derivative. So I'm going to take a few derivatives here. So y is 1 over x. Y prime is negative 1 over x squared. Y double prime is 2 over x cubed. And y triple prime is negative 6 over x to the 4th. So if I plug in, I get xy. So I get 1 over x times x plus x squared times negative 1 over x squared plus x cubed times 2 over x cubed plus x to the 4th times negative 6 over x to the 4th. And so x times 1 over x is just 1. X squared times negative 1 over x squared is minus 1. X cubed times 2 over x cubed is plus 2. And x to the 4th times negative 6 over x to the 4th is minus 6. If you clean that, you get negative 4. And then lastly here, we're going to basically solve for a, b, c, and d. So I see I need y, y prime, y double prime. I have y. Y prime will be 6x squared minus 8x plus 5. Y double prime is 12x minus 8. So we'll plug in. So I need 2y. So 2 times all of y will be 4x cubed minus 8x squared plus 10x plus 2 plus 3y prime. So I'm going to multiply that all by 3. So I have 18x squared minus 24x plus 15. And then minus 2y prime. So I'm going to multiply this by negative 2. And then I get negative 24x plus 16. Negative 8 times negative 2 is plus 16. And now we're just going to combine like terms. So I have 4x cubed, that's by itself. Negative 8x squared plus 18x squared is plus 10x squared. We've got plus 10x minus 24x minus 24x. So that's minus 38x. And then we have plus 2, plus 15, plus 16. So you end up with plus 33. So then you just pattern match here. So ax cubed, 4x cubed, a is 4. Bx squared is 10x squared, so b is 10. Cx is negative 38x, c is negative 38, and d is naturally 33. So hopefully I didn't make any silly mistakes here. But this is just a quick intro into verifying solutions for differential equations, a very quick intro into differential equations. we will continue working with them in the sections to come.